All right. All right, you guys, today's demonstration time. What we're doing today is taking a 3G, 4G test. It is a single-sided bevel at 45 degrees with a 1/4 inch gap, okay, between our two plates. So it's a bevel on one side. This is a groove weld. It's in a vertical position and an overhead position using 1/16 wire. Now this material is known as ASTM 514. It's actually a higher tensile strength. It's actually between 80 and 100 PSI. So it's some strong stuff. The wire that we're using is Fabco 803. And 803 is known as an 8,000 wire. So that wire is basically 80,000, 90,000 PSI, also matching pretty close to the strength of the material that we're welding out. 514 has different grades. This grade is specified as a grade that is 100,000 PSI. Something that you have to be mindful when you prep up your plates. There's enough videos out there on prepping up your plates. I don't need to go over that. But something that's unique about this, and what I did when I prepped these plates up, was that I used a brand new grinding wheel and a new flapper disc. I made sure that all my surfaces were clean, and clean with the new wheels. Why I did that was because if those wheels were used as subpar material before, and if it somehow actually, I want to say, impregnated my surface of my material, I don't want that to be a condition that affects the testing of these specimens once I cut them from the coupons. So again, with this material, because it is 50,000 PSI higher than 836, when you're dealing with 836, it is a lower tensile strength, and I don't want that to be on the surface of my material if that were to happen. When you grind material, a lot of times that material will actually bond to whatever you're grinding with. So it'll actually be in the pores of your grinding wheels. The grinding wheels do wear and that comes off, but there is a chance of actually grinding that onto your material. Why take that chance? Grab a new wheel. Make sure that you don't use that same wheel to grind off something off the table and then touch your coupons to it. You're trying to create a very clean surface for your coupons to bond with the spiller metal. This is actually going to be bent, tension tested, and certified at a point that this welding procedure is a proven, solidified welding procedure. Preheat is going to be very important with this procedure. Okay, so the WPS for this says 250 minimum is the preheat. We'll take it up to 300 on our preheat. Inner pass temperature, according to D11, for 514 is not to exceed 400 degrees. Again, 400 degrees is inner pass temperature. So when you look at the D11, it specifies that up to 2.5 inch thick steel. Once you get above 2.5 inch thick plate, then it goes up to 450 degrees Fahrenheit for your inner pass temperature. So we have a window. Our window that we want to maintain these plates at is 300 to 400 degrees Fahrenheit. So let's stick to it and let's make this a successful test. I'm going to make this video in segments. This is the setup. I have my vertical here. I could get to it very well. I can see my groove here. I have my layout. I can see it very well. Okay, make sure you're positioned so you're comfortable. I have this is basically my elbow bar. It's in a good, comfortable position. Something that's very, very important, you guys. This is a dual shield wire. Okay, it's flux core and it's shielded with a 75-25 mix. You have to drag it. You have to have a drag angle. I'll say between 10 and 15 degrees. You're dragging that nozzle uphill and you're dragging that nozzle along the overhead. Okay, very important. This is a drag. This is not a push. You're dragging it. Remember that old saying, if there's slag, you drag? Yes, you want to drag this. Very important to clean between the passes. I have my wire wheel ready to go. Okay, so we're set up. I'm gonna preheat my plates, get them up to temperature. I'm gonna start welding them out. I'm not gonna record the whole ordeal. It's too much time, okay? This is basically a 4-hour test. So I'm gonna condense it into sections. This is the setup. The plates are set up, ready to be welded. They're clean, they're positioned. I'm in a comfortable position as I'm gonna weld. Remember, I'm gonna drag. My parameters for the voltage on the welding specification, it says a minimum of 25 volts. All right, minimum 25 volts. So I'm gonna start at 25 volts. I actually had a test piece and I actually did some stringers on it at 25 volts with different wire speeds. My wire speed for my overhead was really solid at 200 inches per minute. And on my vertical, actually between 150 and 175 looked better than 200. Okay, so it was a little bit slower on my wire speed on my vertical and a little bit faster on my overhead. Now, you're welcome to, flip-flop, stick to one speed and work with it. It's up to you and how comfortable you are. Let's get to it.